Okay, guys. Good morning. Welcome back. Today we're going to be talking about 6-3, solving systems using elimination. So far, we already know how to work with the graphing method and the substitution method for solving linear systems. When we're solving a linear system by graphing, we're simply solving for y in y equals mx plus b form, and then we're graphing each equation individually, and the point at which they intersect is the solution to that system. If they never intersect, that's because they have equal slopes. That means they're parallel lines. There will be no solution. Sometimes they'll give you a line, and they'll give you the line but written in two different ways. But when you simplify it or graph them both, you realize that they overlap each other, and that is an infinitely many solutions response. For substitution, we learned that we have to find and isolate one variable, the easiest variable to solve for. We plug in that value into that variable of the second equation. We solve for the remaining variable. Once we have that value, we plug it back into the original equation, and we find the second variable. Today, we're going to be talking about elimination. Now, I love elimination, and I think it's the easiest one, but that's because I'm really good at multiplication tables, and I can find common factors and common multiples really easily. If you can do that, this is going to be a joke. If not, I suggest you beef up your multiplication skills. So let's get right to it. Elimination method. What is the solution of the system of equations? They give you two equations here, okay? And in substitution, we would start solving for either the x or the y. We're not going to do that anymore. With elimination, what's going to happen is as follows. Number one, line up the equations variable to variable. What does that mean? X to x, y to y. Okay? So that's what number one means. And add the equations together, making sure that one of the variables is eliminated. So if I put a big plus sign here and I add these together, what's 4x minus 4x, gentlemen? 0. That cancels. So what's 2y plus 3y? What did you guys say? 5y. Very good. And that equals 9 plus 16? 25. Divide by 5. Y equals 5. Now that you have that, that was step one. You added them, you lined them up, you added them. Step two, substitute the value of the variable you just solved for into either of the given equations and solve for the other variable. So now that I know that y equals 5, I can plug this y, guys, into either this one or this one. It does not matter. It does not matter. You can go ahead and plug that into anything. So which one do you want to plug it into? Okay, he wants to plug it into the top equation. So I've got 4x plus 2y, y is 5, because we solved that, equals 9. So you subtract 10 to both sides. 4x equals negative 1 divided by 4. X equals negative 1/4. So my solution is negative 1/4, comma 5. Okay? Can I check this? Sure, plug it back in. 4 times x, which is negative 1/4, plus 2 times y, which is 5. What's 4 times negative 1/4? Negative 1. What's 2 times 5? What's negative 1 plus 10? 9. It works. Let's plug it into the second equation. Negative 4 times x, which is negative 1/4, plus 3 times y, which is 5. What's negative 4 times negative 1/4? 1. What's 1 plus 15? 16. It works. So you can check these just like you can check substitution. Does that make sense? All right. Yeah? Okay, let's do this. Let's continue. Now, that was the easy one. They're going to give you nice and pretty easy ones sometimes. By easy and pretty, look at what I mean. See how I have a 4x and a negative 4x? When you add those together, they already cancel out, right? Well, sometimes they're not going to give it to you so pretty. What is the solution of the system of equations? Sometimes you will have equations that do not eliminate easily. Look at what I'm saying. Does 2x and 3x, do they eliminate easily? 7y and 5y, do they eliminate easily? No. In these cases, you need to line up the equations, which it is lined up, variable to variable, and create an equivalent system by multiplying each side of one or both equations in the system by the same non-zero number. Okay, what am I talking about? First of all, what do you guys want to get rid of, the x or the y? The x. Okay. Think about negative common multiples. What is the first common multiple between 2 and 3? It's going to be 6, right? So we want one of these to be positive 6x, and we want the other one to be negative 6x. Are you guys with me so far? So I'm going to multiply to this top one 3 to everything. To this bottom one a negative 2. Good job. Now distribute. That's going to be 6x plus 21y equals 12. It has to be distributed to everything. Remember, you're multiplying to both sides. Yes, sir. Okay, if you have another method, that's fine, but I'm not going to teach that way. Thank you, though. Now, I have negative 2, which I'm going to distribute. So that's negative 6x minus 10y plus 10. Does everyone see how I got my new values, my new equations? Guys? Okay, now. Yes, sir.
Why is it negative 6?
So, thank you. The question was, why is it positive 6x and negative 6x? Because I want to cancel them out, don't I? So now when I add these, what's 6x minus x minus 6x? Cancels. So I got negative, bless you, positive 11y equals 22. Divide by 11, y equals 2. Yes, sir.
Does it matter which one you make negative?
The question was, does it matter which one you make negative? No. If you wanted to multiply the top by a negative 3 and the bottom by a positive 2, that's fine. But one has to be positive and the other one has to be negative. They have to be opposite integers so you can cancel them out, sir. Thank you, sir.
But give you something where like lined up on top of each other where you be allowed to move it around so it was before you start.
Okay, the question was, if they had put 7y plus 2x equals 4, am I allowed to go 2x plus 7y equals 4? What's the answer to that, guys? Yes. What property allows you to move around addition problems? No. What property? Commutative property of addition. The commutative property of addition and multiplication state that you can change the order of an addition or multiplication problem without changing the answer. So now that we have that y equals 2, now what? How do I solve for x? Yes, sir. You can evaluate it to the first or second equation. It does not matter. Where do you want to evaluate it to, sir? The first one. So I've got 2x plus 7 times y, which is 2, equals 4. So I've got 2x plus 14 equals 4. Subtract 14 to both sides. 2x equals negative 10 divided by 2. X equals negative 5. So my solution is negative 5, comma 2. Does that make sense, gentlemen? Are you sure? I think that this is easier. It really depends on everyone's different. Yes, sir. You can use, when you're plugging in to find the second variable, you could use either equation, sir. Either equation works. Yes, sir. Yes, sir.
When you know how you multiplied everything?
Yes? No, I didn't. Okay. Oh, I see what he's saying. What he's saying is when you're checking, Mr. Morrow, you went back to the original problem. Yes, I did. This part is what you have to convert to solve the first variable. But once you have the variable y equals 2, you can plug it into that y or that y. You have to plug it back into the original equation. If you listen, if you hear, it says substitute the value of the variable you just solved for into either of the given equations and solve for the other variable. Does that make sense? Promise? Yes? Okay. Let's continue. All right, now, what are the solutions for the following systems? Okay. These are some special systems. Here I'm already set up, right? The x's can cancel out immediately, right? So I'm going to add these together. What's negative 3x plus 3x? Boom. What's y minus y? Oh, wait a second. And then 0 equals 0. Is that a true statement? What have we said about true statements? Infinitely many solutions. My friends, we have already been talking about true statements for several sections. It's about time you figure it out already, okay? If it's a true statement, that means that they're the same equation. That means the solutions to one are the solutions to the other one. So that means that there are infinitely many solutions, gentlemen. Number two. Okay, when you add these here, the x's cancel, the y's cancel. Does 0 equal 16?
No.
That is a false statement. So false statements, what solution is that then? No solution. So this is the same thing. It's not like we're adding something new. Does that make sense so far, gentlemen? You sure? May I continue? All right. Okay, let's do this. Use elimination to solve the system. Okay, let's look at this right quick. Do I have to manipulate anything or does something cancel already? Yes, sir. Very good, son. You can cancel out the y. So when it's set up for you here like this, nice and pretty, go ahead and add them. It's going to be 8x equals 8 because the y's cancel. So divide by 8. Very good, son. X equals 1. Now I can plug that x into either that one or that one. I don't care. Which one do you want to plug it into? Because I don't care. Okay. So I got 2 times x, which is 1, plus 5y equals 17. Subtract 2 to both sides. 5y equals 15. Divide by 5. Y equals 3. My solution is 1, 3, and I can check it. Does that make sense, gentlemen? You promise? Sir?
I noticed that you did all these different than exercise 2. You multiplied 3 and 2. Like,
That's because I had to manipulate the variables. If I don't have to manipulate the variables, guys, I don't have to multiply anything. Look, this original question, the 5y and the negative 5y already cancel. So I'm not going to bother manipulating anything. Sir? You cannot cancel out the x here easily. You would have to multiply this top one by negative 3 to make it a negative 6. You could solve for either one you wanted to. How can you solve for a number, son, if it's a number? A variable is what you solve for because a variable is an unknown value. You can't say 6, solve. 6 is 6. Yes, sir. No. The question was, can you manipulate the equation have no solution? No. Because if you multiply this by a negative 3, yeah, you get negative 6x, but now you get negative 15y. Are the y's going to cancel then at that point? Okay. My friends, I know what you're doing. You're trying to find shortcuts. Stop. That's the problem. There is no shortcut here. Do it the right way, please. Sir. Okay, the question was, why don't you have a 0 equals 0? Son, when you added these, that canceled, that canceled, that canceled. You were left with 0 equals 0. In this one, son, when you added these together, you're left with 8x equals 8. How is that 0 equals 0? Next. Is there anything that I can eliminate easily here? No. So what do you guys want to solve for? Sir, he wants to solve for the x. Okay. So what do I need to make that 5x and what do I need to make that 3x? Okay. Okay, he's going to choose to multiply that by negative 5 to both sides. With a positive 3. Very good. Because one has to be positive, one has to be negative. Excellent, son. So you're going to get, after you distribute, 15x minus 27y equals negative 129. Excellent. Plus a negative 15x minus 40y equals negative 340. Very good. Thank you, guys. So this 15x minus 15x, they cancel. So I've got negative 67y equals negative 211. That is wrong. When the signs are the same, you add and keep the sign, son. So this is going to be 469. So we're going to go ahead and divide that by negative 67. And my answer is going to be negative 7 on the money. I promise. 67 times 7. 7 times 7 is 9. Bring over the 4. 42 plus 4. 469. Like I said, it's very... Yes? I'm sorry. That is a negative, so it would be positive. Now that I have a y equals, what do I do now? Sir? Plug it into where? You can plug it into the original top or bottom. You want to plug it into the bottom one? That's fine. 3x plus 8 times y, which is 7, equals 68. 3x plus 56 equals 68. Subtract the 56 to both sides. 3x is going to equal 12 divided by 3. X equals 4. So my solution is 4, comma 7. Does that make sense? Yes, sir. Thank you. Okay, we already answered that question. The question was, does it matter if I multiplied the top by a negative 3 and the bottom by a positive 5? The answer that I had already said once before is no, it doesn't matter. What does matter is that one of these values has to be a positive and one of them has to be a negative. Does it matter which one? No. Thank you. Next. Okay. Now let's put this to use. A music store offers piano lessons at a discount for customers buying new pianos. The cost for lessons and a one-time fee for materials including books, music book, CDs, software, etc. are shown below. What is the cost of each lesson and the one-time fee for materials? Now, you have to think for this one, okay? Hold on. First, let's define our x and our y. What would our x be? Okay, he wants to make x the one-time fee. I'm very proud of you, son. And then y is the number of lessons. I am very proud of you. That is the start of a great answer. Now, what are the two equations, bro? Take your time with it. I know you got this. X, which is the one-time fee, plus 6y equals 300. Stop for a second. X, which is the one-time fee, plus 6 lessons equals 300. True or false? Okay, what's the second equation, my brother? Hold on. X, which is the one-time fee, plus 12 times the number of lessons, equals 480. No, I don't mean y times the number of lessons, because y is the number of lessons. We already defined it up here, sir. That's why it's very important to define. 12 is the number of lessons for the second equation, which is the second equation that I wrote. Thank you. Now, yes. Okay, we're going to go through this one more time. X we chose as the one-time fee. If you want to make y the one-time fee, my man, God bless you. We made y the number of lessons here. If you want to make y the one-time fee and x the lessons, great. But we have chosen this way. So no, y is not the number of one-time fees. It is the number of lessons because we have defined it already. Okay, sorry about that. Had a little bit of a snafu there. Okay, so now how do we solve? Subtract the bottom equation? Wrong. That's different. You said subtracted. First you got to multiply by -1 down here. So you're going to have x plus 6y equals 300. And then plus a negative x minus 12y equals negative 480. So x's cancel. I got negative 6y equals negative 180. Y equals $30 per lesson. Okay? And then, hold on. Now that we know that y is $30 per lesson, we need to know what the one-time fee is. What is the one-time fee? Then how do we figure that out? Plug it in. So x plus 6 times 30 equals 300. X plus 180 equals 300. Minus 180 to both sides. X equals 120. So there's a 121 time fee, and then it's $30 per lesson. And that's what my boy was asking me before, and he's right. Y is not the number of lessons. Y is the, I guess, the charge per lesson. Okay, so it's the charge, the amount of money they charge per lesson. So thank you, son. Does that make sense, boys? Are you sure? These are the word problems you're going to see on the test. It's going to be nonstop, over and over and over. So let's do another one. Let's do another one. All right. The theater club, guys, the theater club sells 101 tickets for $164. A student ticket costs $1. An adult ticket costs $2.50. How many of each ticket were sold? Yes, sir. What do we do first? Yes, sir. What does x equal? What does y equal? Good start. Okay, no. X is the number of student tickets. We already know that it costs $1, so that's not a variable. So x is the student tickets, and then y will be the adult tickets, okay? Excellent, son. I love the way he said that. First, your totals equation. X plus Y, student tickets plus adult tickets equal 101 tickets in total. And then? 1x, now my values equation. $1 for every X student ticket plus $2.50 for every Y adult ticket equals $164. Fantastic, son. Okay, how do I solve this, my brother? You got this. You could have multiplied the top or the bottom by a negative. He wants to basically eliminate the x, okay, guys? I'm going to do it to the top just so you see it doesn't matter. Multiply -1 to every single thing. So I'm going to have negative x minus y equals negative 101 plus 1x plus 2.5y equals 164. Go ahead and subtract these bad boys. The x's go bye-bye. You're going to have 1.5y, excellent son, equals, no, 101 minus 164 would be, no, it'd be 63, sir, right? And then you divide by 1.5, or for those of you who don't like division, doesn't 1.5 turn into 3 halves? What did I tell you to get rid of? How do we get rid of that fraction? You multiply by the reciprocal. So 2 over 3 to both top and bottom. It's going to make your life a lot easier. 63 divided by 3 is 21 times 2 is 42. So there's 42 adult tickets. How on earth do I find how many student tickets that I have? Plug it back in. X plus 42 equals 101. Subtract the 42 to both sides. X equals 9. That's gonna, you gotta borrow, so that's gonna be 59. So my answer, 59 student tickets and 42 adult tickets. My friends, these are the word problems you're gonna see. Sir.
Not the total of the tickets, but the value of each student. And you have to go to the second equation to fix the value for it.
Yeah, well, that was weird. You know how much each student spent already, $1. And you know how much the adults spent each, $2.50. Okay, please do not start packing up. Let me give you one more, at least set it up. Okay? This is a good one. Washing 2 cars and 3 trucks takes 130 minutes. Washing 2 cars and 5 trucks takes 190 minutes. How long does it take to wash each kind of vehicle? What do we do? Hurry up, man. Or let's just call X cars and Y trucks, okay? Shh. Okay, so we've got, you mean 2X, 2 cars, plus 3 trucks, 130 minutes. 2 cars, plus 5 trucks, equals 190. And then from here, guys, eliminate. But that is the equation. Yes. Have a wonderful day. May God bless you. Homework for part 1 is valid. Have a great day, guys.